Good afternoon, good morning, wherever you are. My name's Arij Al-Zubaidi, Content Marketing Executive at Erlang Solutions. Thank you for joining us today. We're joined by the team behind Forward, a leading e-health chat app, who will share their experience of migrating from a closed solution to XMPP. We're honoured to be joined by three speakers today. Philip Mundy, founder and co-CEO at Forward. Mirek Szymanski, technical lead from Miquido, working with Forward. And Ludwik Bukowski, software developer at Erlang Solutions. This webinar is a continuation of a series of webinars run by Erlang Solutions, highlighting the most innovative and exciting work from the Erlang and Elixir communities. This month, we're shining a light on XMPP and Mongoose IM. Before we get started, we'd love to hear from you. You can tweet at us using the hashtag Erlang Solutions Talks, or submit a question for the Q&A session using the questions box on the platform. As a reminder, a recording of the webinar and the slides will be shared after this webinar has ended. Please keep in mind that this is a live event and that we may experience some technical issues, although hopefully not today. Now let's get started. Over to you, Philip.
Hi, thank you for that introduction and welcome everybody. We're really proud to be talking about our project because it's a really meaningful application of messaging technology, and it's one of those use cases where you really can't afford to get it wrong. So I'm just going to spend a few minutes introducing the problem and our very high-level approach to it, and then the engineering team behind the project, who made it all possible, will give you more in-depth information into some of the approaches and challenges that we faced. So I've tried to outline at a very high level what Forward is trying to do. Doctors and nurses all over the world need to communicate as the basis of providing care. It's hard to believe, but in hospitals everywhere, the radio pager, known as the bleep, is still one of the primary modes of communication. Recently, clinical teams have been using WhatsApp as a workaround because it's a very reliable and easy way to share instant messaging with friends or colleagues. But the problem, of course, is that it was never designed for the clinical setting. So a year and a half ago, we asked the question. Forward is a group of junior doctors and technologists, and we asked the question, what happens if you try to create an instant messaging platform that would help clinical teams do their job even better? We wanted to find out really quickly if this was a question that was even possible to begin to answer. So we used an off-the-shelf or closed IM platform. Now, that was good in some ways because it helped us build a prototype extremely quickly and start learning more about our problem and about our user community. However, it very quickly became apparent that the limitations associated with such a closed platform meant that we could never really scale the platform to the universal potential that we soon discovered. So approximately 6 months ago, we identified XMPP, specifically Mongoose IM, as a more extensible, more robust and higher performance solution for our instant messaging. And for the last few months, we've been working with the team at Miquido and also the team at Erlang Solutions to replace the closed system with our new XMPP system. And I think you're going to hear now about some of the challenges and also, some of the benefits to that body of work. So with that, I'd like to hand over to my colleague and look forward to hearing about how it was realized.
All right, thanks, Philip, for showing the big picture. Before we start talking about the migration process, I wanted to talk a little bit about the features we had to support. So as you could see on the previous slide, on Philip's slides, most of the doctors use currently WhatsApp for their daily communication. So to win with a mainstream app, we had to build something more than just another chat application. So we implemented a couple of features very specific to our target. At first, we've got the concept of a hospital because each doctor works for some hospital. And then we have teams. And for example, there can be a surgery team Teams are created and maintained by their members in the real life. Each user of the app has a profile in which he can provide information which makes it easier for others to find and identify him, like a specialty or grade. Furthermore, there are patient cards which are similar to traditional cards with patient's information, but with advantages of being easy accessible and easy to share. Patients can have assigned tasks to them, like a task to measure a temperature, for example. Thanks to the list of tasks, doctors can easily track the process of healing of the patients. And then finally we have a chat, which nicely integrates with the above features. On the screenshot, you can see the home screen of the app, which we call the inbox. It's a view probably you are familiar with from other applications. It's simply a list of conversations, including last messages and unread messages count. Then we support push notifications, chat markers, and sending photos. What you cannot find in Facebook Messenger or in WhatsApp is the ability to send patient profile in a chat. I'm going to show how it looks later. As I mentioned, users can create teams. Each team has its own group chat and its list of tasks which should be performed, the task which should be performed by the team. So now I think you've got a good overview of what you can do with the application. As Philip mentioned, we wanted to release the app to the market as quickly as possible. So we decided to start with a ready plug-and-play solution, a SaaS messaging platform. And we think that it was a good approach. We were able to quickly build a working app. The mobile SDK for the platform was well designed. It was hiding all the details about messaging protocol from the app and from us developers. But of course, this had disadvantages. We didn't have an access to the source code of the SDK. We didn't know the internals of the protocol, so it was sometimes difficult to debug the problems we had, and sometimes we were limited by the platform. After some time, we could say that app was successful, so we decided that we should invest in our own messaging platform, mostly to have more control over it. The choice was to use XMPP protocol and to cooperate with Erlang Solutions, which provides Mongoose IM, which is an implementation of the XMPP backend. Ludwig, can you tell us about the background of the XMPP protocol?
Yes, sure. Thank you for that, Mirek. So basically, I will do the short, brief introduction, which is the XMPP. It is a protocol, which is the open standard, which means that you can basically modify it because it's open sourced. And as a standard, I mean that it's officially approved by Internet Engineering Task Force, and it has its own RFCs. Except of that, it's kind of extensible solution, which I mean that you can build the custom extensions on top of what's basic provided by this standard, and it gives the possibility of decentralized architectures, which means that you can have whole federations of the server. It was done firstly by Jeremy Miller in 1998, and since that the technology was improved and many open sourced servers written in many languages were created. One of them is Mongoose IM, which actually came from the first project, which was the EdgeBird. It's written in Erlang because it's Erlang and it's good in message passing solutions. So can you tell us, Mirek, how was it to implement the XMPP from scratch from the perspective of someone who didn't have any clue about the protocol before?
Sure. Yeah. So for me, as a developer switching from SaaS solution, a few things were quite surprising at the beginning of the migration. So there's no high-level mobile library for XMPP. We had to understand details how the protocol works. At first, there's a concept of a stream, which is a connection over TCP, and it provides a way to send and receive XML messages, which are called stanzas. And the messages are sent between server and the client. Then there's a backend, which in its basic configuration does almost nothing more than just passing messages between clients in real time. It doesn't store any messages. It doesn't contain any advanced logic unless you turn on some optional modules. Ludwig, you know the backend side better. Can you tell us more about it?
Yes, I can add to this point that basically server doesn't modify the content of the message itself. It only relies on the attributes, XML attributes of the message, which is like who's the sender, who should receive the message, and what is the type of the message itself. It can be chat, group chat, or headline, for example. So you can actually put any like content or body based on a namespace to make it more flexible for client-side users.
Yeah, so basically, I can say that I was quite surprised by the simplicity of the backend. Next thing is our chat markers. Coming from the previous platform, we were assuming that to provide chat markers, we have to mark each message separately. But in XMPP, marker is actually a normal message, a pointer in a conversation, which means that all previous messages were, for example, delivered or read. For the server, it's a normal message as any other message. At the beginning, I mentioned that in the app, we've got an inbox screen with a conversation list with unread messages count. You would expect that using a protocol with such a long history, implementing this would be easy, and as it must have been done by many companies before us. But it appears that the XMPP doesn't support such feature out of the box. We will talk about how we implemented it later on, but maybe Ludwig, can you tell us about the background of the problem?
Yes, actually, there is no good reason why it wasn't presented as an extension in the first place. Maybe there were more than one reason actually. But basically, the clients usually relied on the roster extension, which means that you can have a friend list and you can ask for a last message with the people you have in those list using another extension, which is the archive, message archive management. So actually, this approach is quite heavy in terms of the traffic and in terms of how many messages needs to be exchanged between server and the client. So honestly speaking, there were some workarounds on that, but there wasn't pure extension for this particular feature on the server side.
Yeah, and just to add to this, in forward we couldn't use roster because actually we don't have a concept of address book, because like almost everybody in the directory in the system is our contact. So it didn't make sense to use roster in our case.
Yes, that would be heavy.
Yeah, didn't make sense at all for us. So the next thing is the feature offline messages. As I mentioned, the core backend is designed to pass messages between clients in real time. So someone may wonder what happens when someone sends a message when the recipient is offline. For that, there's the offline messages feature. That sends the messages to the client that were sent to him when he was offline. But it appears that this feature doesn't guarantee that all messages will be delivered, and it delivers them only to one of the user's devices. We also wanted to have control over amount of the messages that we get from the server when the app starts. So we ended up disabling the offline messages. Next thing is the MAM, which stands for Message Archive Management. It's a feature on the backend side which allows to store messages for later retrieval. What has surprised us here is that the messages returned by the MAM have different IDs than the messages sent by clients. It seems like a minor thing, but it had some implications on our solution, and it was quite confusing at the beginning. Ludwig, what is the reason why the MAM has its own message IDs?
I think it was a problematic issue because basically client can set the ID of the message on his own. And there might be the case, like scenario when someone uses the same ID for each message, or the messages are duplicated, message IDs are duplicated, or I send the same ID with the guy who I'm talking with. It means that when I try to filter such a archive, let's say, give me last 10 messages starting from this message. And when I will set the ID of the message, it will turn out that there might be more than one such a message. So we needed to make sure that every ID is unique, which means that it had to be generated by server. We cannot rely on the clients because they are unresponsible.
Yeah, well, for us, it actually meant that that querying MAM was basically more complicated than we thought it will be because of the separate IDs. Okay, the next thing is our timestamps. So again, since the core backend only passes messages, there is, in normal case, there is no need to send a timestamp with every message. But in our case, we need to display the time when a message was sent. And for that, we needed to implement a custom solution. Ludwig is the one who implemented it on the backend side. Can you tell us more about it?
Yeah, so basically there are timestamps in the messages, but only in terms of messages stored in archive, which means that when you ask for some history of conversation, you will have a timestamp for each message because it's timestamp when it's written to archive. The problem was when we exchanged the message in TCP connection that is alive, we didn't have those times and dates when it was sent. And actually, there might be some problems when the phone device changes his date on the phone, or we just have a long conversation and we want to know what actually was the time of the message when it was sent in the live TCP stream. So we just decided to timestamp every message by server when it's sent.
And I'm not sure, you can correct me if I'm wrong, but I think we are going to open source this feature, right?
Yes, of course, and it's worth mentioning, we are going actually to open source Inbox as well, which is like a good step for our community, I think.
Yep. All right. More challenges. When we send a message in communicator, we want to know who has sent it, what was his name or his nickname. By default, XMPP uses only internal IDs called Gs to identify sender and recipient. There's no need for extra. There is a need actually for extra mechanism to provide the name of the participants in the conversation. So we ended up sending names in each message, which is maybe not perfect, but it works fine for now. Maybe we will change it in the future for some more optimal solution. Another challenge was to have control over multiple sources of incoming messages. So they can be received as online messages, which are basically messages passed by the server when both sides of the conversation are online. Next, we have offline messages. These are the messages sent by the server after we come online that were sent to us when we are offline. As I said before, we ended up turning this feature off. Another source of the messages is MAM. These are the archive messages. And finally, we have inbox, which returns last messages of all conversations, including unread messages count. So it was quite a challenge to organize the code, so we know what's the source and how to handle it, and to not duplicate the code too much. Ludwig, can you tell us about the architecture of our system?
Yeah, so basically overall architecture is quite simple. It contains of 3 elements, which are the devices, iOS and Android devices, Mongoose IAM as a XMPP server, and backend service, which is actually authentication service, your custom service that Mongoose IAM is connecting to. And we use actually just 2 protocols, which is XMPP, as mentioned before, and HTTPS for communication between devices and backend, and Mongoose IAM and backend. So more deep architecture we can see on the next slide. If you can, Mirek, change it. Yeah, thank you very much. This is the backend architecture of Mongoose IAM. So basically, we use, as I said before, except the XMPP REST protocol. We use them for creating rooms or sometimes fetching the history, etc. Moreover, the Mongoose IAM is connected to Postgres database, which we think that's ODBC-based databases are nice and proven. And the rooms are stored there, the archive, the inbox as well. So this is our place where we keep all data. We connect to your custom authentication backend to authorize authenticate users during the connection process. And we have separate service called Mongoose Push. It's our open source project, which his task is basically to forward the push notifications. So the messages that were sent when someone was offline, it communicates with FCM and APNS services and forwards the pushes to the phone itself. We separated this logic because it's kind of huge work to do, and it gives more flexibility when you want to extend the, let's say, what type of notification you can send. Mongoose IAM has like modular architecture. It means that we have blocks we can plug in or disable or enable. For example, it's inbox that we talked before, a group chat, offline messages, archive, this timestamp module. So the whole idea is that we can just easily add blocks to our architecture and make it more, let's say, containing features and flexible. So maybe over to you, Mirek. Can you talk us more about the client-side architecture?
Sure. I can talk about Android because I was actually working directly with Android. iOS platform is probably designed in a similar way. We spent quite a long time actually thinking how to design the architecture so it's easy to extend and maintain. So as you can see, we have the Mongoose XMPP backend on the server. Then on the mobile side, we use the SMAC library, which is open source, low-level library. Then the SMAC library communicates with the server over the XMPP stream. Then we have built our internal high-level SDK on top of SMAC. The SDK has its own SQLite database to cache messages and other metadata. And then finally, there is the application which communicates with the SDK using Rx Java and custom events. Okay, so that's the overview of the Android architecture. Now we'll go through some of the features and tell how we migrated them from the previous SaaS platform to the XMPP. I'll start with the home screen with unread messages count. You can see it on the screenshot. It seems like a simple screen, but it's quite a challenge to implement. So before the migration, the external SDK provided a conversation object which contained all the data we needed. It contained the last message, it contained unread messages count. When something has been changed in the conversation, for example, the counter was changed, the SDK delivered this information to the application using events. It was very convenient to use, and it worked actually quite well. So during the migration, we decided to do something similar. In our SDK, we also introduced this concept of conversation, but before everything happened magically in the SDK, now we had to handle it by ourselves. And for example, we had to handle a couple sources of information for the conversation, because conversation object can be updated by the messages coming from inbox from the backend. We actually query for inbox on every reconnection. Another source are the online messages. So for example, when we have the app in the foreground, the incoming message will increase the unread messages count. The next source is the application itself. For example, when user sends a new message, we also have to update the inbox with the last message. So we have to deal with all the sources. The result is that the application itself remained almost unchanged, which I think is a good thing, and because we were able to hide many details in the details of the protocol in our SDK. So how did it look on the backend side, Ludwig?
So the first glance, it doesn't look at all because there wasn't inbox, as I said before. So we had to struggle together with Miquido team to create a completely new specification. We just were working together and thinking about how should the protocol and the whole flow looks like. We ended up with a feature that gives us the conversations with another user, and per each conversation we have a number of unread messages, last message, and we supported everything with a Postgres database. It has good integration with message archive because we make sure that every last message is the same message that is taken from the history, the conversations, so it's well synchronized. As I said before, good integration with offline messages because we can know how many messages unread there are, with push notifications and chat markers. In terms of chat markers, we reset the unread conversation once the user sends the chat mark and that it was displayed. So when we displayed the message, we actually reset the unread counter for the specific conversation.
Okay, I'll just add to that internally here at Miquido, we had a lot of discussions how this feature should work, and actually at the beginning I was against introducing this feature at all, but later we ended up, I think, with quite a nice solution. And again, this will be something which will be open sourced, at least on the backend side. So I think it will be useful for the community. Okay, the next feature is are chat markers. For example, send or read. Chat markers is the handy feature that shows the ticks, which mean that the message was sent or read. You can see them on this screenshot on the right. Probably you are also familiar with that feature from other messaging platforms or applications. And how did the migration look like? So on the SaaS messaging platform we used before, the magic was happening in the external SDK. Almost everything was done automatically. All we had to do was to mark each message as read. It was done in the application, and also we had to handle the events to show the ticks when the state of the message has changed. After migration in the XMPP, we decided to use existing extension called simply chat markers. And in the XMPP, the marker is as a normal message, almost normal message. When we send a marker saying with attribute displayed, it means that all the previous messages has been displayed or read. So we don't have to send a marker for each message, and we better not to do it because there will be too many messages in the stream. Our SDK has to keep track of the timestamp of the markers. So we have to keep some metadata with the conversation object to know which messages has been already displayed or sent. So we provide all this information to the application. And again, we managed to keep the application almost unchanged by keeping all this logging and handling the markers and in the SDK. Ludwig, how did it look on the backend side?
So generally, in ordinary message exchange, the message with chat marker is untouched. So we don't mind if it's chat marker or just normal message. So it just go through the whole system. But at some point when we were creating the inbox specification, we needed to think how to resolve the issue with the offline messages, how to mark that the message was read. So we just use the chat markers. When the server sees the message with chat markers namespace, it just resets the counter for this conversation. Moreover, we had to add the feature that the chat marker is not in the content of last message in inbox conversation, because we wouldn't see the content of the body, we just would see the tick, which doesn't give any information. So we just don't store chat marker as a last message in inbox. We store the text that someone wrote something and we want to keep it as a last message. Moreover, we can have the configurable backend so that we can store them or not in the Postgres. current installation stores all chat markers. So when we ask for archive, we know which messages are read by whom in group chat, for example.
All right, makes sense. Let's go to another feature. Group chat. It's something which is actually very similar after the migration that was before, but basically by the migration we were able to get rid of the limitation of the SaaS platform. So previously we had the limit of the group size to 25 members. Now it's virtually unlimited. So we have from a mobile side, this change was quite straightforward, except for handling some IDs of the conversation, but it was not actually very maybe challenging. And on the backend side, Ludwig?
On the backend side, we decided to use the migrate extension, which stands for multi-user chat lite extension. It's our custom protocol we wrote because the classic multi-user chat was not fitting the requirements of the clients sometimes. Creating the rooms and sending messages is available by the stream, XMPP stream, and REST endpoint as well. We store the rooms in Postgres database. We can store them as well in the Amnesia, which is Erlang base database, but we decided to keep them in ODBC based solution. In the current configuration, we don't have owners of the rooms, so everyone can be invited by everyone, and every participants are equal. So we don't have any roles as an administrator or whatever. We just have people in the room talking with each other. In such rooms, we don't have a presence exchange, which was, as I said before, in the old extension of the rooms. So we don't know if someone is available or not. The value we gain is that it's less traffic. Yeah, I think that's all. We can go on with the next features.
And I think you can correct me if I'm wrong, but I think this the fact that there are no room owners is actually a custom feature made for us, right? Because by default, the owner is required to exist, right, in the group chat.
Actually, it is configurable, but there were some things that we needed to fix regarding the REST API and rooms. But let's say it's partially custom for you.
Okay, all right, thanks. Okay, cool. So the next feature is historic messages. Before migration, SDK was handling everything for us. It synchronized historic messages in the background. We didn't have too much control over when it happens, how it happens. SDK just notified the app about new historic messages using events. Of course, application could do some custom queries, but it was limited, and the control over it was limited. In our SDK for XMPP, we synchronize the messages using MAM when the application requests messages for specific conversation that we don't have in the database yet. We might have to add some more advanced logic here, but for now it's working. But it may need some optimization actually later. We managed to keep the application changed. Again, we are trying to hide the logic in the internal SDK. And how did it look on the backend side?
We use an extension called Message Archive Management, and we keep the archive the historic messages for both one-to-one chat chats and the group chats separately in separate tables in the database. We enabled the feature that we can filter by, let's say, last few messages with particular user, or just give me all messages, my whole archive, etc. And pagination feature, which gives opportunity to receive, like, let's say, limited amount of the messages, not everything, but we can ask for limited number of the messages, and then we can ask for more messages starting from some point from the history. So it's like we change the pages in the book, reading the archive. It gives us the traffic control, so that we don't have everything at once, but we can just slowly ask for more from the archive. I think that's all regarding I mean, there are a lot of features, but those are the most important.
Yeah, and I will just add that for mobile application, the challenge was actually to make sure that we don't have like holes in the history of the messages that we keep locally. So we have to get the message from mom with some carefully designed algorithm. Okay, and the next feature is about sending patient profile. You can see on the screenshot how does it look. User by clicking the big plus sign or button, he can attach to the conversation patient profile, and the recipient can click on this to see more details about the patient. Internally. We used before migration, we used the feature of the SDK, the feature that each message actually contained message parts. Each part contained some binary contents and also a MIME type. So the application used a custom MIME type, and we serialized the patient profile data and send it to the recipient. After migration in the SDK, we used some similar concept. We also had a message with a custom MIME type, and we serialized the patient profile and attached to the message. Almost the only change that we made in the application was the way we serialized the patient data. Previously, we used some custom serializer and the serializer, and currently we use JSON because it's a standard currently. So it's the best way to use, we think. How do you look on the backend side, Ludwig?
Actually, as a message goes through the system untouched, we didn't even realize when you introduced this feature because it's completely client-side extension. So there's no change from the backend side. You just put whatever you want in the body, and the server will just forward that to the recipient.
Yep, exactly. Okay. I think that's the last feature on our list, the feature called timestamps. Before migration, the SDK provided timestamp out of the box. Timestamp is simply the time when the message was sent, so we can display it and we can sort by it. And as I mentioned in the XMPP, it's not provided out of the box, so we had to use custom timestamp extension. We actually backend attaches the timestamp to each message, application we were able to leave the application almost unchanged. And how we look on the backend side?
We create the separate data tag, which is XML element. We add timestamp to it, and we support it for both one-to-one and group chat messages. And actually, another advantage of using this timestamp is the fact that when we ask the inbox, we can have the timestamp of the last sent message. So that's another reason we added it for our inbox feature.
Yep, and yeah, we use it all the time.
I hope it's working.
Yep, it is. Okay, so let's compare the solutions that we have, or that I had the experience with. So, so for the SaaS messaging platform, the major thing is that it's a closed solution. Everything there works as a black box. We don't know what's happening inside. We can just guess. So sometimes it's okay, sometimes it's even good not to know too much maybe, but when it comes to debugging, solving some problems, it's actually a limitation. Another thing is, or actually very related to this, is that the SDK that was provided with this platform was very high level SDK, which made creating the application quite easy and relatively fast. That was a good thing, and it was actually a very well designed SDK, so we could learn by using it. It was hiding all the internals of the protocol, so yeah, we didn't have to know how it works internally. We hit some limitations. For example, the size of the team was limited to 25 members, which was definitely not enough for us, and it was quite a big factor that yeah, that we didn't want to use it anymore. Also, the platform provided very good APIs. For example, we could access historic messages using some REST API. We could request for archive. Everything there was very well thought and designed, so it was quite nice to use. When it comes to XMPP, we don't have this high-level mobile SDK. For both iOS and Android, we can use only some low-level libraries like Smack on Android. You definitely need to know more how the protocol works. You have to know how the backend works, what's happening there, what it does to the messages, and what it doesn't. All it gives us, for example, that it's much easier to debug. We have access to logs. We have access to the source code of the libraries and of the sources of the backend. So we don't have to, blame the other side that something is wrong. We can debug a lot by ourselves. XMPP was designed to be extensible, and we can see that in practice. We can see how we can turn on and turn off some modules and features. We can use some existing extensions, or we can also create our own extensions. And in our case, we had to create like two extensions. So it worked in practice, actually. We decided to build this higher level mobile SDK to hide some of the internals of Smack, for example. Smack gives us a lot of features, but to use it directly in the app, I don't think it would be a good idea. Another maybe a disadvantage is that now we have to maintain the infrastructure by ourselves. For example, we have to create tools and to have tools that to monitor the infrastructure, whether the servers are working fine. so yeah, it's not provided out of the box. Okay. Let's go to the migrations summary. Yeah, some of that probably I already said. So SMAC is a low-level library, easy to extend. It gives us some core features like reconnection mechanism. Without it, it would be difficult to work with. And it hides all the handling of the XML messages. What else? So we created the internal SDK. We hide in the SDK all the logic, and almost nothing leaks to the application. So yeah, we were able to minimize the changes that we had made in the application. Thanks to that, we had I think not too many bugs, because we didn't touch almost any existing logic. Overall, I would say this process of migration to XMPP was very challenging, but I would say satisfying task. So it was fun to work on. How did it look from your perspective, Ludwig?
So basically, when we worked together and we started to testing all the features, we firstly figured out that like some extensions are not covered at all in XMPP, which was the inbox, and some solutions we had wasn't really fitting the requirements. So the good example is when we tried to add the pushes, the push notifications, and we had as a title of the notification the username of XMPP user, which was the JIT, which is the part of the username. We have @ and we have the domain. So actually, it was quite unwanted when we were using the application, because we didn't even know who wrote us the message, because we had just pure username, not the real name and surname of the sender of the message. So we needed like covers such additional fixes on top of that. Except of that, as always, we found some new bugs on the server side regarding the REST API. Like specific usage when we combined it with the group chats and REST API, there were some things that didn't work correctly, and even had some problems with the memory leaking when we were triggering the notifications in like special configuration of the server. So actually, this is the thing that you cannot really test it on your own. If you I would rather say that it's hard to test it. It's hard to think about more complicated scenarios, because it depends on the configuration and how it's used, how the flow with the client really is. It's quite a complex problem to find some bugs on the server just by pure testing, writing the test. So it was very, very nice for us, like nice experience. I think that's all, and as you said, it was very challenging to work with you, and we enjoyed the work together to create this whole application from scratch, actually.
Yep, it was quite a big project. And speaking about tests, that's why you have testing environments, right?
Yeah, of course, but some cases are like super hard to think about it.
Yeah, it's hard to predict every scenario.
Yeah, but all tests we add to our open source storage of tests, and we still extend this continuous load testing and continuous testing environment we have.
Yeah, and just to add at the end, so the migration is almost done, but we actually, it's an ongoing process. We still continue working on the application and on the server, so it's not like completely finished yet. And I think it's all for us. So I wonder if anyone has some questions.
Thank you, Philip, Mirek, and Ludwig, for that deep dive into XMPP or Forward. There was lots of insight there into the inner workings of the features of a working chat app, so thank you very much for that. We received a number of questions during the presentation, but before we jump into the Q&A session, just a reminder to the audience that you can still submit a question to the panel. I'm going to take Philip off mute. Okay, so the first question is, was it worth it to migrate to XMPP?
So maybe I can tell from my side. I think yes. Oh, okay, well, Philip, go ahead.
Was it worth it? Well, we're still doing it in a way, because I think what's important to note is that these migrations are not quick, nor are they simple processes. So we have already started benefiting from the decision to migrate, but I think the true proof will be when the platform scales from a few percent of our target user group to tens of percents of our target user group, which is what's happening right now. So we'll absolutely keep everybody posted, but I'd say so far it's looking promising.
Okay, great. Thanks for that, Philip. We have another question from Nicholas. What about privacy? What security do you provide, as health is quite confidential?
Would you like to?
So I think I could answer part of it, but then I think that obviously there'll also be a technical description of how we do it.
Mm-hmm.
So I think part of the security for Forward is by design. So in terms, it's a closed network. You have to request access by submitting your NHS or approved whitelisted email address. The platform is then essentially opened to you. Further, we have additional PIN locks on the device after periods of inactivity, and patient information is only available to those who are invited to join specific teams. The details around how we achieved that, I think Mirek could probably give more information.
Yeah, so in technical terms, we actually use encryption wherever you can, actually. So for example, all the messages are sent using encryption. Also, when we communicate with the backend, we use HTTPS, and the data on the devices is also encrypted. So I think thanks to all this, I think we are quite sure that all the data is available only to authorized people.
Okay, thank you very much. The next question: how many man days did it take to migrate to XMPP?
Not sure. Maybe okay, I can try to answer. So from our look like we had about like 2 people per each platform. So 2 people on iOS, 2 people on Android, 2 people on backend, for example, or one backend guy in Miquido, and I don't know, 1 or 2 guys at Erlang Solutions. So
I was alone most of the project.
Oh, you were alone. Oh, okay, yeah. And
most of the project, sometimes Dominic helped me.
Yes, and we had also testers, 1 or 2 testers, and a PM, and everything so far lasted for about 3 or 4 months. It depends how to count it. So I hope the answer makes sense.
Get your calculators out. Okay, well, I think we've made time. Thank you very much, Philip, Miroslav, and Ludwig, for joining us and sharing all this information with us. It's very, very interesting. If anyone has any further questions, please do email us at webinar@erlangsolutions.com, and we'll get back to you with responses. But for now, thank you very much and have a good day.
Thank you.
Thank you.
Thank you, guys.